Welcome back. So where we had left off, we said, okay, we have this angle here. What can we figure out if any of these angles are equal to it? Well, we know that alternate interior angles on, this is a transversal line right here, and these are parallel lines. So we know alternate interior, so this is an interior, and its alternate interior is here. So we know they equal each other. I'm not going to draw it yet because sometimes if you forget alternate interior, you could just remember, well, corresponding angles equal each other. So you could say that angle is also equal to this angle. And then you can use opposite angles again to kind of get back to the alternate interior. I'll show you. In math, the great thing about math is it's good for people who have trouble memorizing things. You have to just memorize a few things, and then everything else just kind of falls out of it. But anyway, so we figured out that this angle is the same as this angle, right? Because they're alternate interior angles. And this is its corresponding side. And then finally, what about this angle here? I'm going to draw a triple angle. 1, 2, 3. What is that one equal to on this triangle? Well, same reason, alternate interior angles of two parallel lines. And remember, the only reason we can kind of make this claim is because I told you at the beginning that that this line right here and this line right here are parallel, right? Otherwise, you couldn't make this claim. But since they are alternate interior, we know that this is the same angle. All right. So we now have shown that these are similar triangles, and I didn't have to do all three angles. I could have just done two, and that should have been good enough for you to know that they're similar, because if two are the same, then the third also has to be the same. And now let's see if we can use this information to figure out our ratios. So let's see. Let's color the sides the same side as the angle so we don't get confused. So this side is the orange side, right? This side is the blue, this side is red. Okay, so we have everything color-coded. And it might be confusing you, but it's useful because, as we'll see, these triangles are actually kind of flipped. So let's see what we can do. So we know we need to figure out this orange side here. So this orange side here, let's call it x. So x equals question mark. This orange side here corresponds to this side here, right? Because it's opposite this angle, which is equal to this angle. So they're opposite to the same angle. So that's how we know they correspond to each other. So we could say x over 6 is equal to, and now, what other sides do we know? Well, we know this side here. We know this 4 side. Let me do it in that color. We know this side is 4. And since we put x in the numerator on the left-hand side, and 4 is in the same triangle as this x we're trying to figure out, we'll put 4 in the numerator on the right-hand side. 4 over what? Well, what side corresponds to 4? What is opposite this angle right here? Well, it's this angle, right? So 4, the corresponding side of this side is 5. And now we can solve. X is equal, we just multiply both sides by 6, so you get 24 over 5. X is equal to 24 over 5. Not too bad. And then we could even go further. We could figure out this side is right here, this magenta side. Let's call that, I don't know, y. Not too creative here. Well, y corresponds to this angle, so y corresponds to this 8 side, right? So we could do y over 8 is equal to, we could do a bunch of things. We could say 4 over 5, or we could do let's do 4 over 5, because we could do 24 over 5 over 6, and that's kind of confusing. So we could also do that is equal over 4 over 5. Multiply both sides by 8, and you get y is equal to 8 times 4 is what? 32. 32 over 5 equal to 32 over 5. And the reason why I did this example is because I want to show you that you can't just eyeball necessarily. Sometimes you can if you get good at it, but it's not always completely obvious which sides correspond to which sides. It might have been tempting to say that, I don't know, this side corresponds to this side, or that this side corresponds to this side. But you really have to pay attention to which side kind of matches up with which angles. So any side that matches up with a certain angle, that same angle in the other triangle whatever side is opposite that, that's its corresponding side. I use a lot of words, but hopefully I'm giving you have a bit of an intuition. Let's do another one. First, let's take a triangle and prove to ourselves that the two triangles are similar. So let's say, I like these parallel lines. Let me do two parallel lines again. And then this time around, let's see, let me draw, there's a line, and then there we go. This is kind of a neat example. Well, first, I said these are parallel lines, so let me mark them as such. Parallel lines. So what we want to do is we want to prove that this triangle right here is similar to the bigger triangle, is similar to this triangle. So this is pretty interesting. They actually overlap, right? So first of all, do we know any angles in the two triangles that equal each other? Well, sure. They have this angle. They actually both share the same exact angle in common, right? Because the two triangles overlap at that point. So what else can we figure out? So let's see. I don't want to be tacky with ugly colors, but let's see. So let's see. We have this angle. We have this angle here. And what other angles are equal to this angle? Well, we can use our parallel lines and transversal angle rules and or theorems or whatever and figure it out. Well, this angle corresponds to what? Well, it corresponds to this angle, so it's equivalent. And you got that from your parallel lines, right? So these two are the same. And then finally, if I have, let me pick a good color. If I have this angle, draw a triple angle here, same thing. This corresponding angle is going to be right here. So there, we know all of the three angles of this triangle are the same. So this is a similar triangle. And so if we knew that, let's say we know that this side right here, I'll give you a little trick question. From here to here is 5, and from here to here is 7. From here to here is, let's say, from, I don't know, from here to here is, I'm going to make up a good number, is 12. And from here to here is, oh, I don't know, let me think of let me say 9. No, let me say it's 6. And I wanted to figure out what this is. How do we do that? And I've further made it more confusing by adding all these squiggly lines. Well, we already know that these are two similar triangles, so we can use that information to do our ratios. So if we call this is equal to x, right? So what do we know? We know that this whole side corresponds to what side on this smaller triangle? Well, it corresponds to this side, right? It corresponds to here. So let me draw it in the correct color. So if we do the orange, this orange corresponds to this, right? While this orange corresponds to the whole thing. It corresponds to this whole line. So if we take the big triangle side is not just x, right? Because that's not the whole side of the triangle. It's x plus 5. So we could say x plus 5. That's this whole side, right? Over x plus 5 over the corresponding side on the smaller triangle. Well, on the corresponding side of the smaller triangle, it's just this. It's over 5, right? Is equal to, and then we could say, well, 12 is equal to 12, because this corresponds to this angle on the big triangle. It's equal to 12 over what? Over 6, because this is a smaller triangle. Over 6. And then we could solve for that. This becomes 2, right? You get x plus 5 is equal to 10. X is equal to 5. There you go. X is equal to 5. That's all the time I have for now. I hope I helped you understand similar triangles just a little bit. I'll see you soon.